Welcome to video 2. We're going to continue talking about our quadrilaterals, but we're going to talk about them with the inclusion of their slopes. So first we need to have a little discussion, a little reminder from your Algebra 1 days about what parallel slopes look like, because some of our quadrilaterals have parallel sides, and some of our quadrilaterals have perpendicular sides to them. And so we need to talk about, if I were to give you these slope values of each side of my quadrilateral, would you be able to prove to me and tell me whether that there are parallel sides present or not, or perpendicular sides or not? So first, parallel slopes were equal to each other. Parallel slopes were equal to each other. Now, you might watch out, because I might try to trick you in some cases and say, like, what if one side had a slope of 1/2 and another side had a slope of -2 over -4? You might go, no, those are different. No, wait a second. -2 over -4, that simplifies to be 1/2. And hey, those really would be parallel to each other. So keep in mind, if I give you a slope, it may not necessarily be a fully simplified fraction. And you should always try to fully simplify your fractions to see if they truly are the same or not. Now, perpendicular slopes, on the other hand, see if you remember this from your Algebra 1 days, but perpendicular slopes had to have two things going on with them, and that they were negative or opposite, as some of your algebra teachers might have worded this, negative or opposite reciprocals. And reciprocals was, if we had a fraction like a over b, then its reciprocal, we just flipped the numerator and denominator, and the reciprocal would be b over a. Now, what I mean by negative or opposite is that if, let's say, one slope was b over a, then the negative reciprocal is, well, this fraction altogether is positive, so I would want to make the perpendicular slope negative, and then I need to flip the fraction, which I almost forgot to do there, so it'd be negative a over b. Well, what if the beginning slope was negative a over b? Well, then I would recognize that, hey, this is negative, so I need to take the opposite sign, or make the negative negative, which is now positive, so then it would be a positive, flip the fraction, b over a. And if you want to put a little plus here, you can. It just emphasizes the point that we are taking the opposite sign of our slope. So again, parallel slopes, the same. Perpendicular slopes are negative or opposite reciprocals of one another. Now, there's also going to be another case where I might try to trick you, and that is going to deal with zero and undefined slopes. Now, a zero slope, if we think about rise over run as being slope, if you had a zero slope, then that zero corresponds to the rise. And the run could be, well, whatever. I mean, the run could be 1, the run could be 2, the run could be, I mean, really any number you wanted to put down here in the denominator, because 0 divided by any number that's not 0 is going to be overall 0. So if you have no rising going on in your slope, but you have running, then a zero sloped line would be a horizontal line. And an undefined slope, again, if we thought of the idea of rise over run, undefined fractions was when you had 0 in the denominator, but then you could have whatever you wanted to in the numerator, as long as it wasn't 0, because 0 over 0 is not technically undefined. It's a special case. So now if I have whatever as my rise, I can rise up and down however much I want to, but I can't run anything from left to right, then an undefined slope, it's kind of a poor example there, but I'll write the word next to it, would be a vertical line. So 0, horizontal line, undefined slope, a vertical line. And horizontal and vertical lines are naturally perpendicular to each other. And again, what do perpendicular lines create? They create 90-degree angles. Do we have any quadrilaterals this chapter that have 90-degree angles in them? Absolutely, like squares and rectangles. And even some other shapes besides squares and rectangles could have 90-degree angles in them. And we'll even talk about some of the properties of our quadrilaterals. That we'll talk about diagonals specifically of our quadrilaterals. And some of our diagonals will be perpendicular to each other. They'll create 90-degree angles. All right. Now, before we get into the actual nitty-gritty part of the video, a couple more vocabulary words. I just need to make sure, because over the years I've had students not 100% grasp what I meant by opposite sides and what I meant by adjacent sides. Okay? So we're going to talk about opposite sides and adjacent sides in two ways. We're going to talk about what you would naturally think we would talk about with opposite sides, and that's going to be the lengths. So if we talk about the lengths of the opposite sides, well then you guys are pretty squared away with that, like the top and the bottom, or the left and the right, for instance. But we could also refer to the opposite sides in a different way. And instead of length, and then here's the new emphasis, is in terms of the slopes. So if we looked at the slope of the opposite sides, well, what type of relationship might we want to show is true about opposite sides, besides maybe they're having the same length? And so this is where our two P's of this video come into play, parallel versus perpendicular. And opposite sides can be shown to be parallel, but opposite sides can never really be perpendicular to each other, right? We can't have opposite sides of each other making 90-degree angles. They're never going to run into each other because we have these other opposite sides in their way. So if we ever refer to opposite sides, again, we might be talking about their lengths, or we might be referring to their slopes. And again, opposite sides, we're going to want to try to show maybe parallel sides. Now, on the other hand, if we want to talk about two sides that are right next to each other, then we would refer to those as adjacent sides. And so in some of our quadrilaterals, we might want to show that the adjacent sides are congruent in length. But in terms of slopes, what might we want to show is true about adjacent slopes is we may have a 90-degree angle. And so what type of slopes would we need to have that are adjacent to each other to show that we had a 90-degree relationship? We would need to show that these slopes were perpendicular. And mathematically, what's got to be true about perpendicular slopes? They need to be negative or opposite reciprocals of each other. So we will look at opposite slopes for parallel lines, and we're going to look at adjacent slopes to determine if two sides are perpendicular to each other. Now, in terms of perpendicular, there might be, 4 potentially 90-degree angles here. So that means we could be looking at, let's say, these two adjacent sides. Well, here, let me just do this. These two sides could be adjacent to each other and be perpendicular, or these two sides, or these two sides, or these two sides. So in terms of adjacent sides, there's really kind of 4 sets going on here. But back with opposite sides, we only have 2 sets of opposite sides, right? We've got these 2 opposite sides, and we've got these 2 opposite sides. So adjacent, there's a little bit more to discover there, a little bit more to explore. All right, so now we're going to look at 2 examples here. And in these 2 examples, and then the third one is going to be for you guys to try out. But in these 2 examples, I have given you whoa, that was way off center there. Let's try that again. The D right here is going to represent the distance, aka the length, of each of the 4 sides. And the M right here, M is going to represent slope. And so based on the 4 lengths and the 4 slopes, you got to try to figure out what name, what is the best name, because we could just say, this is a quadrilateral. Hey, great job. Yeah, it's a 4-sided shape. Good job, it's a quadrilateral. But does it have a better name than just quadrilateral? So let's take a look at what we got here. So I just drew kind of a generic quadrilateral. Okay, so I'm not saying that, hey, this is what the shape's going to look like, and you're going to go, rectangle? Like, that's what it looks like, just based on what I drew here, but I'm not saying it's a rectangle. And then you might go, square! And like, no, come on, calm down. I didn't say it's a square. Let's just look at what the numbers tell us it's going to be, all right? So first, let's look at all 4 sides here. So I'm going to label the four sides with their length. So AB, so here's side AB, this is square root of 33. Side BC, over here, root 15. CD, root 15. And AD, root 33. Now, we're going to explore kind of both ideas of lengths and slopes, but I would prefer doing them one at a time. So here's my 7 unique quadrilaterals, if you will. We've got trapezoids, isosceles trapezoids, kites, parallelograms, rectangles, rhombuses, and squares. And so just looking at the side lengths here, are there any of these 7 special quadrilaterals that we can automatically throw out the window? Because we know for sure it's not any of those based on just the side lengths alone. And you might go, well, hey, a square has 4 congruent sides, and I can clearly see there are not 4 congruent sides here. True. Anything else that has 4 congruent sides? Well, rhombuses have 4 congruent sides, so we can throw that out the window. Now, you might already have a good idea of what it's probably going to be, but we're just going to whittle this thing away kind of one at a time. And you might go, rectangles. Well, true, but rectangles by definition are parallelograms with 4 right angles. And so, do we know for sure that this is a parallelogram with 4 right angles? You might go, yeah, but opposite sides of rectangles are the same. That's a property that's true about rectangles, but we're just going to, for right now, stick with the definitions of what these all are. So I'm just going to kind of stop with the distances, with the lengths, because I definitely know it's not a rhombus or a square. But let's go explore the slopes now. All right. So what am I going to be looking for in the slopes? I'm going to be looking for parallel slopes, aka slopes that are equal to each other, or negative/opposite reciprocal slopes, because those would give me perpendicular sides. So first let's talk about parallel. So AB and CD are opposite of each other. So if I focus on those slopes, are they the same? And they're not. 2/5 and 6/7 are not going to be the same. They're both fully simplified. So I know these two sides not parallel to each other. All right. Now, I could go ahead and cross something off my list here. I could cross 2 things off my list because I know that these 2 sides are not parallel. A parallelogram, by definition, has 2 sets of parallel sides. And I know this thing's not going to have 2 sets. So it's not a parallelogram. A rectangle, by definition, is a type of parallelogram. Well, if I've already squashed out parallelogram, then there's no way it could be a rectangle. All right, cool. Now we're down to 3 options here. Let's go check out the other opposite sides. Side BC and side AD. So the left and the right sides. Are they parallel? And I look at these 2 slopes, and I'm looking at those numerators. Ooh, those are looking nice. But the denominators don't match up. So the left and the right sides, not parallel. So, any other shapes here that have at least 1 pair of parallel sides? Why, there is. A trapezoid has at least 1 pair of parallel sides, and this had no parallel sides. And an isosceles trapezoid is a special type of trapezoid, so it gets thrown out. So that leaves us with 2 possibilities. And you might go, whoa, 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 Mr. G, you've only got 1 left here, a kite. True, but who said this had to be any of these special quadrilaterals? The answer in the end could just be quadrilateral, and you had to look through and eliminate all 7 of these choices. So let's explore a kite. The definition of a kite was that it has 2 sets of adjacent congruent sides. So 2 sets of adjacent congruent. These 2 sides are adjacent to each other, and they're congruent in length. There's 1 set. Here's another pair of adjacent congruent sides. There's a 2nd set. So this is by definition a kite because it has 2 sets of adjacent congruent sides. All right. Now, you can kind of think of this as like playing the game, what was it called? Guess Who. If you ever played Guess Who as a kid, you had one person that you were trying to figure out amongst all these other people, and you had to try to eliminate all the people that were not the person you were looking for until finally you were left with one person and you were like, oh, definitely this person is, in this case, a kite. So we're going to try to eliminate all the other suspects that are definitely not the shape we're looking for until we whittle it down to just one final shape. All right, second example here. So again, let's first take a look at lengths. All right. So AB up here, square root of 45, cool. BC, square root of 30, awesome. CD, square root of 45, fantabulous. And AD, the square root of 30, exemplary. How'd you like those adjectives? Weren't they fun? So are there any shapes that we can throw out the window here? And again, just like in the last example, we definitely know this thing's not a square or a rhombus because all four sides would be the same. So is there anything else we could throw out? And you might go, what about a kite? Didn't we just say in the last example that a kite by definition had two sets of adjacent congruent sides? And if I look at these adjacent sides, they're not congruent. And if I look at these adjacent sides, they're not congruent. And if I look at these adjacent sides, they're not congruent. And if I look at these adjacent sides, they're not congruent. There are no sets of adjacent congruent sides. So yeah, let's throw kite out as well. But now let's go look at the slopes. No, we'll keep that there. Let's see. Okay, so slopes. Now notice, there's a bunch of zeros in here. We talked earlier about something with zero slopes. Oh yeah, zero and undefined. There was always a zero in place. And remember, for a zero slope, the run, I didn't give a specific number here, but I said it couldn't be zero. And for an undefined slope, notice, remember I put a question mark here that it could be any number you wanted to, but it couldn't be zero again. So let's jump back to here. Now, 0 divided by 3 and its opposite slope for CD is 0 divided by negative 1. And at first glance, you might look at those and go, those aren't equal. 0 divided by 3, 0 divided by negative 1, those aren't the same exact fractions. And I would agree with you. They're not the same exact fractions. But what is 0 divided by 3? It's 0. And what's 0 divided by negative 1? It's 0. So both the top and the bottom sides have a 0 slope. So I can put some parallel line markings here. So I do have one set of parallel sides so far. Now, can I throw out any of these just because I have one set of parallel sides? I cannot yet, because all of these, by definition, have at least one pair of parallel sides. So then we go look at the other set of parallel sides. Not parallel sides, sorry. The other set of opposite sides is what I should have said. And again, we look at these and we go, no, they don't look like they're the same. But again, any number divided by 0, as long as it's not a 0 up top, it's an undefined slope. And 6 divided by 0 is an undefined slope. So you know what? These two opposite sides, they both have undefined slopes, and they're going to be perpendicular to each other. So let me put some parallel line markings on here. And so now I have two sets of parallel sides. Well, this is sounding more like a parallelogram or maybe a rectangle. So trapezoid and isosceles trapezoids typically just have that one set of parallel sides. Now I know by definition we say that they have at least one pair, but typically you can think of your beginning roots of learning shapes, and trapezoids still typically have that one set of parallel sides. So now we've boiled this down to parallelogram, or is it a rectangle? Well, what's the difference between the two? Well, a rectangle is a parallelogram, but it has 90-degree angles. So now we get to a point where we need to test one more thing. And does this shape have 90-degree angles? And again, don't just look at this and go, well, clearly, angle A, B, C, and D, those look like 90-degree angles. But remember, I just drew a generic shape A, B, C, D. So don't just assume right out there on me that this is going to be a rectangle. What we need to look at next are the adjacent slopes to each other. So let's say we look at the first two slopes in our list, slope AB and slope BC. And so remember, if adjacent slopes are negative reciprocals of each other, opposite reciprocals, then they're really perpendicular. Now, when we look at these two slopes, when we go 0 and undefined, I don't know, are 0 and undefined slopes perpendicular to each other? Man, I don't remember. Let me go back. Oh yeah, 0 and undefined slopes are always naturally perpendicular to each other. Because remember, we really end up having a horizontal line meeting up with a vertical line. And so those are going to be natural 90-degree angle makers. Nope, too far. So looking at the adjacent slopes, then we can for sure say that AB and BC will be perpendicular to each other. So that deserves a 90-degree angle there. Now, do we get to put all four of these angles to be 90-degree angles? Well, you would need to go look at the next set of adjacent slopes. So the next set would be side BC with side CD, right? BC, CD. And undefined and 0. Yeah, those are naturally perpendicular. So we do get to put another 90-degree angle here. And then what about the next set of adjacent slopes? Well, that would be CD and AD. Well, here's CD, here's AD, 0 and undefined. Once again, naturally perpendicular, 90-degree angle. And then the last set would really be looking at side AD with side back at the beginning, AB. So technically, even though it looks like there's two sets of sides in between AB and AD here in this list, really AD kind of goes back around to AB. So it's almost like a circular list instead of a linear list. But undefined and 0, we do get another 90-degree angle here. So we have two sets of parallel sides and we have 90-degree angles. So this is where this part now comes into play. Determine the best name for this quadrilateral. Well, technically, both could be called a parallelogram or rectangle, but which one is the best name that most precisely defines this shape? That would be the rectangle. So this thing is a parallelogram, but it's a parallelogram with some extra stuff going on, which therefore gives us our rectangle name. Now, the last example. I want you guys to try this one out. And the next day in class, we will discuss this one to make sure that you've got the correct answer. So good luck. And again, remember this ABCD that I've already drawn here is just a generic shape for you to label your sides or to label parallel or 90-degree angles on. And that is all for video 2.